So we're continuing on with guided practice 10.9, and we have here problem number 5, and it is a problem with two secants that are entering a circle. And again, our formula is the outside times the whole of one of the secants equals the outside length times the whole length of the second secant. Let's go ahead and create our equation then. For the first secant, the outside part is 8. The whole part is x plus 8. I could also write 8 plus x. It doesn't make a difference. And for the second secant, the outside piece is 6 in length, and the whole secant is 2x plus 6. So this is my equation. I have to solve for x. I need to distribute 8 over x plus 8. This would be 8x plus 64. And here I distribute the 6 over 2x plus 6. That gives me 12x plus 36. Now I've got to subtract. It doesn't really matter the order I do this in, but I'm going to subtract 8x from both sides, giving me 64 equals, this would be 4x plus 36. And now I'm going to try to get 4x by itself on the side. So I'm going to subtract 36 from both sides. And 64 minus 36 is 28. I have 28 equals 4x. X therefore equals 7. Okay, so the answer to number 5 is 7. Let's go on to problem number 6, which is right next to it. Okay, so let me zoom in just a bit so we can see this problem a little bit better and maybe decide how our strategy should be. So now we've got two chords that are intersecting in a circle, and what we have to do is, if we remember for the first problem, we look at each chord and we look at the two pieces that it was broken into, the lengths of those two pieces, and we multiply them together. So one chord is broken into a length 8 and a length 10, and the second chord is broken into a length 6x and a length 4. So we just multiply 8 by 10, set it equal to 6x times 4, and then we solve for x. This gives us 80. This gives us 24x. We have to divide both sides by 24 in order to solve for x. That gives us x equals 80 over 24. Okay, and we can reduce that a fair amount. So we always want to give our fractions in lowest terms. Clearly 4 goes into each one. That would be 20 over 6, but we still have, they're both even, so 2 still goes into each one of them. That would give us 10 over 3. So we divided 80 by 4 to get to 20, 24 by 4 to get to 6, and I had to divide them each by 2 again because that wasn't the greatest common divisor. So 10 over 3 could be an acceptable answer, or if I wanted to express it as a mixed number with a fraction, I could say it's the same as 3 and a third. Okay, so x equals 3 and a third, or x equals 10 thirds, are both acceptable answers. Well, let's go on to number 7. So number 7 is a kind of problem we've seen already. This is a problem with two secants that are going into a circle. Okay, so this is a secant, and so is the bottom one. We'll notice that in this case the x is in the outside of the second secant. So let's go ahead and remember our formula. So the outside of one secant times the whole secant, the length, equals the length of the outside of the second times the length of the whole second secant. So let's move this up a bit. Let's do our work on this. And we know we're looking at 7. Okay, so the top secant, the outside is 4. The whole length is 4 plus 2, or 6. The bottom secant, the outside is x, and the whole length is x plus 5. So we just need to go ahead and solve this. 24 equals, we'll distribute the x, we get x squared plus 5x. Okay, so for the first time, now we've got ourselves a quadratic formula. We've got a quadratic equality. Okay, so this is The first more difficult one that we've seen that isn't just linear in x, but it's quadratic. Let's go ahead and let's put it in standard form, which means we're going to have to transfer the 24 to the right by subtracting both sides by 24 and setting the whole equation equal to 0. So we've got x squared plus 5x minus 24. Now, when I refer to standard form for a quadratic equation, what I mean is that we've got 0 on one side, and on the other side, the coefficient of the x squared is positive. In this case, what is the coefficient of x squared? It's 1. We don't see a coefficient. That implies that it's 1, and we don't have a negative sign, so therefore it must be positive 1. Okay, good. Well, we've got to solve this. There are two basic ways to solve a quadratic equation. The harder way is to use the quadratic formula, which maybe we might have to do here. I do not know. But the other way to do it is to actually use factoring and try to come up with two factors that multiply together to give 24, but add together to give positive 5. So in order to figure out how to possibly factor this, we have to make a list of the possible factors of 24 in pairs. So 1 times 24 equals 24. 2 times 12 equals 24. 3 times 8 is 24. 4 times 6 is 24. And then we start getting into the factors reversed. So instead of 4, 6, we also have 6, 4. Instead of 3, 8, we have 8, 3. Instead of 2, 12, we have 12, 2, and then 24, 1. We don't have to consider these twice. Okay, so once you start repeating factors, but just in opposite order, we don't really need to consider them. So these are the pairs we're interested in. And we need to look at the positive and the negative here, noticing that we've got a negative value for the product, but we've got a positive value for the sum. So if both factors were negative, we ought to have a positive number here because a negative times a negative would give us a positive. If both were positive, we should also have a positive here. So having a negative here implies a mixed pair of factors, that one is positive and one is negative. You may remember that from Algebra 1. So let's take a look and see. And I think what you'll notice is that we're looking for factors that are a 5 apart, and then we'll worry about the sign later. So 3 and 8 are the only pair of factors that are 5 units apart. Since this is the sum and the sum is positive, it means that the larger number has to be the positive number. So we have to be dealing with a negative 3 and a positive 8. So what does that mean our factors are? It means, well, they're always going to be in this form, x plus or minus something times x plus or minus something. In this case, we've got x minus 3 times x plus 8. Okay, because we have a plus 8 here and we have a minus 3 there, equals 0. Let me write that again a little bit neater. X minus 3 times x plus 8 equals 0. Okay, so that's our solution. But we've got to look for exactly what are the numbers that are the solution. And this is only true. Two numbers multiplied together can only be 0 if one of them is 0 or the other one is 0. So we find our solutions by setting x minus 3 equal to 0, which gives us x equals 3, or by setting x plus 8 equal to 0, which gives us x equals negative 8. Well, let's go back to the picture. Could we have a negative 8 in this picture? Can this length be a negative 8? That's what x is. No, it cannot be 8. Negative 8. It must be a positive distance. So therefore, the only possible answer here is x equals 3. Now you could also get this by trial and error, of course, but it is better to know how to do factoring and how to do solutions of quadratic equations. So let's take a look and verify our answer. If this is 2, this is 4, this is 3, and this is 5, is it true that the outside times the whole of the top one, which would be 4 times 6, 4 times 4 plus 2, is equal to the outside times the whole of the bottom, which would be 3 times 3 plus 5, or 8. Are they equal? Yes, they are. So we've confirmed that the answer here is x equals 3. So x equals 3 for number 7. And I will finish this up in the next video.